I am happy to be here, right here in this room, in this building, in this city, right now. And I want to get us oriented. So let's start with the time. When are we? When is it right now? Well, here's the date. And September 26th, 2024 is 4 days past the equinox. I write a newsletter every solstice and equinox to the community of Probable Futures and to people who are interested. And I like those days because they make us aware of what we share in common. The equinox, sunrise, sunset, it's 12 hours between them everywhere on the earth on those days. We all have the same deal. And that idea that we share one common planet is central to this gathering. So 15 years ago was what? Well, it was the first Climate Week. And it was there and then, in this city at that time, that people got together because of the global problem, because of what we shared, which was the atmosphere. What was different about the atmosphere? Why did they gather? Well, because the temperature had risen. So this is a graph of the average atmospheric temperature going back to 1850. And the pre-industrial era is 1850 to 1900. You see there it was sort of moved sideways, and then it started going up. And by the end of that graph, by 2009, people were worried. There was a sense of urgency. And that urgency was expressed in Climate Week. People got together for a global problem, and they created Climate Week, and they had mottos. Every year had a motto. And the mottos were in red, in all bold, and they were things like this. They had speed, action, now, fast. The climate decade starts now. That was 2019. There's this sense of urgency, like we gotta solve it. It was very clear, it was singular, it was this global problem. And I understand that urgency, but I think any conversation about climate change, any conversation about how to live with it should actually be reframed in a much slower, longer term sense. It should be anchored to a different time, to 12,000 years ago. Why that time? Why that specific time? Because 12,000 years ago was the last time the climate really changed. It changed fundamentally. And how did it change? It changed by not changing anymore. So this is a graph going back 100 million years of the average atmospheric temperature of our planet. What you can see is on the far left over there, it was very hot, much warmer than now. There were no big mammals. Humans did not gather because there were no humans. It was big reptiles, cold-blooded. Gradually it cooled, and eventually it became pretty suitable for large mammals who generate heat, who offload heat. And around 200,000 years ago, the first human beings were born, people just like you and me. But for 190,000 years, they didn't settle until 12,000 years ago, when the first settlement took place because the climate stopped changing. The stopping of the change, the arresting of the change, changed how humans behaved. And from that point on, we behaved quite differently. We became a more and more and more settled species. We became a more and more specialized species. And so it's a good time to reflect on those 12,000 years ago, but again on where we are now. 15 years since the first Climate Week, this is what's happened to that graph. It's gone from about 1 degree C, at the top edge of that green band, to 1.5 degrees C, which is where we are now. And I appreciate that this can make it feel even more urgent. So the slogan for this year's Climate Week is, "It's time." I get it. Big red letters, it's time. I want to propose that it's time to think a little bit differently about climate change. It's time to think about it not just in terms of decarbonization, of an urgent quest to solve something, but it's time to start adapting. It's time to start living with this changing climate, and we're going to have to do that. And the way to think about that is maybe a little less emphasis on this idea of solving, a little more emphasis on how we're going to live, living in a changing climate, not keeping it at bay, but in understanding it. And to do that, we're going to have to think a little bit less about time and a little bit more about place. And here, we can draw on the wisdom of those 12,000 years, because settlement is about being in place. Settlement is about addressing the future with a kind of confidence, with a kind of awareness, with foresight. And that is at the heart of a settled, civilized culture, is this confidence in the future. And I know we're afraid of the future, but having that confidence needs to enter into our culture. And I want to start with a culture, agriculture. And to do that, I want to get you all to imagine something. And I mean this seriously. I would like you to imagine deciding to plant an orchard. Think about it. You're going to commit yourself. So you're going to choose a species of tree. Then you're going to clear the land. It's going to be a lot of work. And you're going to plant some trees. And then you're going to nurse those immature trees for years without fruit. Finally, you will get some fruit, but they won't really be mature, the trees in this orchard, for probably 20 years. There are a lot of venture capitalists at this session. Imagine pitching this business to a venture capitalist. But also imagine living in a world without the things that grow in forests, but also see why it was so great to have those orchards. So this is a tablet from ancient Assyria. It's thousands of years old. And what I want you to see here is how much labor it was to catch the fish. You can also see how abundant the fish were. Also, how much labor it was to slaughter the hogs. But the date palm trees there are just doing their thing. This is the appeal of the orchard. They sit there quietly, producing the dates, steadily. They're like solar farms or wind farms are ideally. They'll last in perpetuity. They'll just keep being fruitful. And then some really fit, attractive men get together for some casual harvesting at the end of the season. Got some tight pants on, and it's pretty relaxed. And the olives just come down to you. And it's nice. And it may be silly, but that's a very, very old Greek pot. And why is that relevant? Because that long period of stability meant you could keep growing the same thing in the same place. You may have asked, how do we know it was so stable? We know because you could keep growing olives in the same place for thousands and thousands of years. But the olive trees were suited to that green band. They could handle that volatility from -1 to 1 around that 0. And today, 20% of the arable land in Greece is olive orchards. And at the first climate week, the olives were still doing well. Prices were fine. It was in that green band. It was right at the edge. But where we are now is outside the green band. That 0.5 degrees is the difference between what the olives were suited for and not suited for. So this year, Spain lost half of its olive harvest. Sardinia, 75%. Greece, about 1/4. Olive oil prices have skyrocketed. And the reason is, it's a different climate. So I want to show you some data. This is from probablefutures.org, a website you can go to and do these maps yourself. It's the organization I founded with some people who are here with me today. And this shows the frequency, the probability of an extreme year-long drought. And so this is an event that would happen in the past every 20 years or so. It's the extreme of what the plants were suited for. And when you look at this, you see it's all gray, except for the white, which is the desert. But where things grew, a rare drought was rare, 5% chance. But when you went from that middle of the green band to the first climate week, these areas turn a sort of pea green color. And that color indicates that what was every 20 years is now every 5 to 10 years. It's a big change. But remember, at 1 degree, the olive trees were still doing okay. But 1.5 is very different. And this isn't a drought anymore. This is the wrong language. This is aridification. This is a different climate. And the question is, what do we do about that different climate? And the first thing I have to say is, we are at 1.5 degrees now, and we need to plan for 2. We need to also try to avoid it, but 2 needs to be in our planning, and 2 is yet more different. Yellow there is every 3 to 5 years. The darker color is about half the time. This is not a rare event. This is the climate they live in. And I want to reinforce, I'm not trying to undermine the urgency of decarbonization, because higher levels of warming are devastating. At 3 degrees C, they're not growing olives in these places, or dates, or figs. After 7,000 years of it, they're not doing it anymore. So I want to, though, be practical. I asked you to imagine planting an orchard. Now I want you to imagine managing an orchard or helping a farmer with an orchard. So what are the problems? The first problem is that pests enjoy warm winters. Moist, warm winters are good for new pests. The trees, they aren't sure that spring has sprung. The hotter summer makes the fruit mature faster. That's a timing problem. And drought causes fewer, smaller fruit. But what can you do about that? Well, there are strategies. I've spent a lot of time learning about these strategies, talking to farmers, reading journals. And what they can do is they can enrich the soil. They can have new pruning and irrigation techniques. They can actually prune the roots to make them grow differently, to make them more robust. They can have better weather warning systems for when to fertilize, when to irrigate. And you can plant different species. These are all practical things. You may notice I'm making lists. Adaptation is largely about making lists and following through on them. It is not about grand solutions. And now I'm going to bring it back to you. What can you do? You're probably not going to plant an orchard, but you can imagine life without tree fruits or nuts. You can do that, and it will affect how you think about things. You can get interested in insurance. You can read farmers' newsletters. It's a really interesting way to understand the physical world around you. And you could plant a fruit tree wherever you live. You could participate in this. And if you do that, you'll start to see the world differently, not just from agriculture, but from other cultures. Infrastructure. So I'm staying on the 17th floor in a hotel here. When I look out my window, I don't see much green, but I see lots of physical infrastructure. And what I want to impress upon you is that green infrastructure needs to be adaptive also. These are sort of the standard stock photography of the things we're going to do to make a carbon-free world. What I'm sorry to tell you is that essentially all the building of these things right now is not taking into account the changing climate. So all the tech companies that have pledged to me net zero are building data centers in Arizona without planning for the higher temperatures. And a data center is just a cooling center for machines. It's foolish, it's wasteful, and we need to make that wisdom of the orchard into all this infrastructure. And so I'm going to talk about some pretty mundane infrastructure. I live in Boston. I came here for this. I had 3 options for how to get here. I could take a plane, the red, I could drive, the blue, or I could take the train, the green. And the train between Boston and Washington, D.C. is actually electric. It's electrified. The rest of Amtrak is fossil fuels, but it's the green option. And thankfully, when I came down a few days ago, the weather was mild, the train was on time. That was not the case in the summer. It is increasingly not the case in the summer. It's not the case in the summer because just as those trees in the orchard were planned for a range of temperatures, the rails, the trains, everything was planned for a range of temperatures. And so let's familiarize ourselves with the temperature in this place. Let's look at that climate of the past. So the way this works is the purple tells you that we're at 0.5 degrees C. This is the late 20th century, 1970 to 2000. It's the standard on which we built all our infrastructure. And in this area, just north of New York City, in an average year, there would be 14 days above 90 degrees Fahrenheit. And in a cooler year, 2, and warmer year, a month, basically. And those are the 5th and 95th percentile, so it's a bit wider than that, the full range. That's the range Amtrak planned for. It was a good plan. It was a reasonable plan. But at 1 degree C, that range has shifted, has widened. And at 1.5, where we were this summer, it's now basically a month in an average year, and in a hotter year, it's closer to 2 months, and that's a problem. And at yet higher temperatures, the infrastructure will be under more and more strain, in the same way that the olives are under more and more strain. Now, why is that strain so real? It's because the physical world is interacting with the climate. Infrastructure interacts with the climate. So this is when you're on a train, it goes clickety, 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 click, because there are gaps in the rails. And those gaps are planned. Those gaps are there for various reasons, but one of them is to let the steel expand and contract with temperature. But the space in that gap is engineered for a range of temperatures. And when you get outside that range, the steel pushes together and it buckles and it bends and the rail isn't straight anymore and the train can't go fast or can't go at all. And so the railways have a practical list of challenges that if we don't solve them, they will lose to fossil fuels. Buckling rails, overheated brakes, sagging electrical wires. We are electrifying America and everywhere else, and we're using old standards for the wires. And when you're outside those ranges, those wires sag, they grow less efficient, and they get hotter. And there's heavy demand for air conditioning. All of these are challenges. But actually, Amtrak is dealing with all of these things. If you look at Amtrak's work and the New York Rail, they're painting and cleaning the tracks so they absorb less light. They become less hot. They're upgrading wires, switches, and the trains themselves where possible. You can lay the steel on a hot day. This is how mundane adaptation is make a choice about what day to lay the rails, because when it's really hot, the rails are already swollen. And so they won't swell further, and you won't have the gap problem. And you can lay longer tracks so there are fewer gaps, which is what's happening in Europe. It's a practical list. It doesn't look like inventing nuclear fusion. And what can you do? You all have different assets. Probably not a railway owner. Not a lot of people here are railway owners. But you own something that has risks like this. You can include climate risk in whatever due diligence you do. You can ask if those heat pumps are the right size for the right weather. And you can check for new hazards. You can look for new things. A solar farm is an asset until it is hit by a hailstorm, and it becomes a liability. That's a knowable thing. It's a forecastable thing. It's a plannable thing. But we have to consider, as with assets and liabilities, our values. And in Manhattan, there's nothing easier to talk about than property values. Like if all else breaks down, you just talk about property values, right? Which is why I'm glad we're here. It's a good place to talk about values and about how coastal cities can adapt. Because coastal cities get a lot of attention in adaptation, and that attention is usually from the perspective of the ocean. So let's take a little trip together, shall we, and visit this exact location. Oh, the Javits Center. It's taught in every architecture magazine. The perfect square box, flat, ugly. But I want to point your attention to the orchard that's back there. The orchard of buildings. I love these glass towers and the perfect rectangles. They remind me of stacked piles of money. And that's just how they look on the spreadsheets of all the companies that own them, all the pension funds that own them. They're just stacked spreadsheets, grids of money. But now let's look at it from the perspective of the storm surge. It's pretty delicious if you're a storm surge. There's just so much to wash over. And that's how people thought after Sandy, was we need to protect all these values from the storm surge. So we'll build a force field. We'll build a seawall. But if you've been down to Battery Park, if you looked out, you could wait all day looking for people putting a seawall in the ocean because they're not going to do it. It's too expensive. It doesn't really work. It just shifts things elsewhere. There are no force fields. There are no giant solutions. But this is why I'm glad we're here in this place where people are figuring out what to live with, because there are myriad potential strategies right here in New York City, all over, wherever you live. So what are New York City's challenges? Storm surges, yes. Flooding from cloudbursts is way more common. So the water is warmer. It evaporates more air. Each degree warmer air gets, it holds 7% more moisture. You know what else happens? Cities push warm air up, which causes it to turn into condensation. And so cities in particular are getting heavier cloudbursts. That's a problem. How do you deal with that? You figure out where the streams used to be under Manhattan here, where before we paved it all over. You learn about things, and you start thinking about wet bulb temperatures, that hot, humid air. So how is New York City doing this? I love coming to New York. It's like this place that takes care of you and attacks you at the same time. And there seems to be just too much moisture at all times. This is my second outfit of the day. the city is figuring out how to absorb, store, and transfer that water, to move it somewhere, so it doesn't wind up in basements, in houses, in hospital wards. They're building a few hard barriers, but those barriers don't look like seawalls. But they're learning to mimic those buried streams. And they're developing warning systems. People look out for each other when there's heat. They figure out where to go. We have cooling centers, not for machines, but for people. But all of this, and the reason I'm here, the reason I accepted this invitation, the reason I'm glad to be with you is it starts with education. It starts with being aware of the physical world. And I want to share the New York City plan for cloudburst management. I know this is what you came for. You wanted to come to a city meeting about infrastructure. But this is what a modern day orchard looks like. And it's great. It starts with understanding. And then there's a process. And then there are next steps. You know what this is? This is civilization. This is not solving climate change. This is living in a place, in a community, and it's terrific. You do a cloudburst hub in a specific place, in a neighborhood, because it's a different geography in that place than the whole city. And then come PDFs. And I know you're psyched. There are PDFs. There are going to be PDFs. There are going to be Zoom meetings. I promised to show you a Zoom meeting on screen. You thought you were in person, but we're going to be on Zoom in a second. It's got diagrams. They're helpful. They explain why we're doing this. There's a back-to-school day. There's a family day to teach people about flooding, to figure out what you're going to do about it. It's participatory. It's civic. And yes, there's a layered mitigation flood approach Zoom meeting that's got lots of colors, and it goes sideways, and it's got dollar signs. This is what civilization is. This is what started 12,000 years ago. This is what we need to do to be resilient. And yes, for the engineers, there will be some big, giant doors. Check this out. It's awesome. It's a giant, giant door. Like, this should be somewhere they take 5-year-old kids who like diggers and dinosaurs. Like, check out the door. But also check out the gunk in the sewers you got to get rid of so the water can move. Just maintenance. Maintenance is the most adaptive thing you can do. So what can you do? Figure out the risks for where you are. Go to those community meetings. Volunteer to help local institutions. And if you're in the digital world, create good digital tools. All of this will bring you back to values, community values, in place. And I want to tell you about the winners. I grew up in Michigan, and people now tell me, you're going to move back to Michigan. Everybody's going to move to Michigan. Not too hot, all that fresh water. Well, recently, the lake started going up and down a lot of volatility, and people didn't know why. It turns out because we built civilization also around winter. And so this is the number of days that stayed below freezing in the past. A lot of days, cold. In an average year, more than 2 months where it was below freezing for 24 hours. But that's a wide range, too. There were colder and warmer years. At 1 degree C, it's less. But in the last few years, what's happened is it's so much less, and there are warm February and January days that it doesn't freeze anymore. And when it doesn't freeze, you know what it does? It evaporates. And the lake evaporating is this huge negative suck that's pulling the lake levels down below where the sewers are, below where the water supply is, below where all the infrastructure was supposed to be. And you have more volatility also from heavier rain some of the time. And so the lake levels are spiraling up and down and up and down. And by the end, this map is a different color. And we need to plan for this. This is the place where everybody's supposed to go live. And I want to tell you about an organization that's facing these challenges. What are they? Higher volatility. All the fields in the Midwest, many of them were drained by the US government to make them productive. They now flood again. Then the toxin to fertilizers spread. And the city sewers, just like New York's, are out of date, are too small. But I want to celebrate a social innovation. The Great Lakes Protection Fund, whose logo was made by a dot matrix printer. There are established cultures. This is a document that's their guiding principle. The issue for the Great Lakes Protection Fund, an ecological organization that was supposed to look out for just how the water systems worked, has become a climate adaptation organization. And to do that, they start by explaining we have old cultures, relationships, rules of thumb that reinforce a status quo that is obsolete. And changes to our current water systems must reflect these values, the multiple values. And so what are they doing? They're a little organization of earnest Midwesterners. They're fostering a community of leaders. They asked me to come speak with them, to collaborate with them. They're investing in new monitoring and switching technologies. They're linking financial outcomes to physical outcomes. And they're testing and validating a bunch of new crops. So I want to bring us back to now. With what can you do? You can become more risk aware. You can think and plan in systems. You can strengthen existing institutions. And you can create new connective institutions. That's why we founded Probable Futures, was to support these human values. Because what's happening, to go back to the orchard, to the zoomed out view, the global view of drought, when drought was rare, we were all settled, as were all the plants and animals. At 1 degree, there became some lack of settlement. At 1.5, the animals and plants are on the move. And we have to decide how we stay in place. And at 2 degrees, there will be yet more mobility. And I like doing this here in New York, where 30% of the people who live in this city were born in another country. We need to expand our thinking to think about how lots of things are going to move, because a lot of people are likely to move. And so we have social strategies we can embrace, increasing climate literacy. You can learn about your own local climate. You can join and initiate community groups. And you can prepare to help others. That's why we built this organization. It's why I'm happy to be with you today in this room. Thank you for this time and attention. The QR code will take you to Probable Futures, where you can sign up for the Equinox newsletter and whatever else. But what we do is literacy resources, tools, and executive education. Thank you very much.